A warm welcome to everyone gathered here for the day 4. It's indeed my great privilege to welcome our today's speaker, SABARINATH PREMLAL, founder of Respro Lab. Welcome, sir. It's indeed my great privilege to introduce SABARINATH sir to the hours gathering. Mr. SABARINATH is the founder, CEO of Respro Lab, Chennai. He has also worked as a system engineer for TCS. He has completed his Masters in Embedded Systems from Anna University and his UG from Macca College of Engineering. And he has got several licensed certificates with Microsoft, Google, and he is also a trainer for several skill sets like Python, ABM, ARM architecture, image processing. He has got a very good research experience in terms of Cisco, Intel, Oracle, and he is currently training many students for doing their projects with respect to artificial intelligence, machine learning. With his huge profile, it's indeed my great privilege to welcome you, sir. I hand over the session to Mr. SABARINATH, sir. You can proceed, sir. Welcome, sir, on behalf of PANIMALAR Institute of Technology, Chennai.
Yeah, thank you, Professor. Okay, so yeah, I think is this audible? My voice? If it is not.
Yes, sir. Your voice is audible, sir.
Okay, sure. So myself is SABARINATH. Okay, so I'll be explaining you about what is ML, what is DL, how we can initiate it, and also I'll be explaining you with few mathematical calculations also, how we can able to proceed. Okay, and also I'll be explaining and I'll be giving some demos also. Okay, everything I'm connecting together. Okay, so that's what I'm going to do. That's our today's agenda. Okay. So before proceeding this, I just want to ask some questions to you, the participants. Okay, if possible, they can chat. Okay, so the thing is whether everyone knows what is ML, machine learning. If everyone knows ML, I can able to directly initiate to DL. If no, I can say about ML for 10 minutes, then I go for DL. Okay. Yes, sir. Yes, sir. Okay. The people knows ML already. Okay. That's fine. So by basic, okay, we will be training some datas. Okay. Based on the datas, what we are training. Okay. We will be connecting with the model, okay, the mathematical model, okay, how this model works. Based on that model only, we will be connecting with the deep learning, even the data in a different positions. Okay, so now I'll initiate you with your demo, okay, about how the DL works. Okay, once I completed them, I mean, even yesterday also I connected to the PANIMALAR, I connected the same demo. So today also I will be connecting with the same demo. Okay, so once they completed the demo, their understanding of the DL is a bit different, and I will be connecting with the DL in detail again. Yeah. Yeah. Oh, I forgot to share my screen. I think the screen is visible. Okay. So here I'm having an environment. Okay. So where I'm going to add the multiple boards. Okay. So I'll be taking the real-time images. Okay. Based on that images, we'll be seeing what it is, how it is. Okay. So here I'm having, I'll be initiating the web camera. Yeah. So everyone is visible. Okay. Here I'm having a web camera. Okay. Via that web camera, I'll be taking the real-time images. Okay. So I'm having a AVNet Azure board. Okay. I'll be taking AVNet Azure board. images. Yeah, around 80 images I took. Okay. Then I'll be connecting with the MediaTek processor. So I'll be renaming it MediaTek. Yeah. So I'll be taking the images of around 75 images. I took 75 images. I'll be taking the Kinect processor. So I took around 70 images approximately, and we'll be taking the Renesas. So here also I took the images, and I'm going to take the Raspberry Pi. Also, so I took all these images, and finally I'm going to take the Arduino. Yeah, I took Arduino. So I'm going to train the model. So totally I took around more than 500 images. Okay, just now I took those images. Now I'm going to train the model. So to train the model, it will take time. Okay, so it is connecting to the cloud environment. Okay, it will take time for a few minutes. Okay, maximum of 2 minutes. Okay. Meanwhile, this algo works based on the CNN. Okay. So this is nothing but the classification algorithm. Okay. So here, whenever I'm showing some other board, it classifies under which category is this, under which category is this. So here I'm having only 500 images. If I'm having more than 50,000 images or 5 lakh images, the accuracy is entirely different. Okay. So by basic, it shows I'm an Arduino. Okay. So here, if I'm connecting the MediaTek, automatically it connects. It falls under MediaTek processor. It falls under MediaTek processor. Even if I'm connected to the Kinect processor, it falls under the Kinect and the Renesas, Raspberry Pi, Raspberry Pi. I mean, Azure, it falls. Okay. So again, if I'm not showing anything, it shows I'm nothing but a Arduino. Okay. So the reason behind that is in all the data set, okay, I took only that board, whereas in Arduino data set only I shown my face. Yeah. Here you can able to see it. Okay, in Arduino dataset only, I took my face. Okay, even if my face is seen, it says this is nothing but Arduino. It says this is nothing but Arduino. Okay, so this is a classification. Even if you want to integrate into your projects, if you want to integrate means Even you can able to export the model by clicking this. Okay, you'll be getting a JavaScript for this project and the TensorFlow code also. Whatever you feel is comfortable. Okay, so whatever you feel comfortable, you can take those informations. Okay, so you can integrate into your project also. Okay, the thing is, these things are all easily available. So here, what we did it means we took sample data and train data. We train to the model. Based on the model, it accepts. Whereas in DL, okay, so if I'm showing this board, practically this is Kinect board. Even if I'm rotating, mostly it falls under Kinect board. Okay, mostly it falls under. I mean, it falls under Kinect. Even the data set while we are taken, even the data set in a different positions, the data set in a different positions, it has to recognize it. Okay, that recognition, that mathematical computation is nothing but a real. Okay, the data representation, I mean, by basic ML is nothing but you'll be saying learning the how to cook or learning the how to ride the bicycle. So these things are all ML. Whereas you know how to ride it, but whereas if you are going in highway, okay, suddenly you will be experiencing a different data set. Okay, you will be accepting it and you will be riding it. So those things are all nothing but a data set of how what to be done in a different way. So those methodology is nothing but a deep learning. Those methodology is nothing but deep learning. So even if we are having a big data, okay, so these things are all also is nothing but a deep learning. Okay, so even I'll be explaining with deep learning now. Okay, even I'll be showing one more demo. Okay, I'll be showing one more demo with you guys with audio. Yeah. So I'll be connecting with audio. Here I am going to take some samples of the audio which I'm going to repeat now. Okay. So again, I'll be connecting with some other samples. Okay, I'm be taking maximum of 3 different classes, and I'll be taking the model. So now I'll be showing that audio. Yeah. Hello, 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 hello. So I took those samples for 20 seconds. So I'll be connecting, I'll be feeding these samples. Again, in next case, I'll be taking another samples. Hi, 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 hi. Yeah, I'm extracting those samples also. And finally, I'm adding one more class. Okay. So in this class, I'll be saying something. Pulse, 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 pulse. Yeah. So I took these samples. I'm going to train the model now. Okay. So what we did previously, even I can show with the pose also. Even you can also try with your laptop or the PC. Okay. So yeah. Hi, 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 hi. So you can able to see it falls under the class 2. So if I'm saying about the pulse, 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 hello, hello, hello. You can able to see the data visualization happened at this output. Okay. So it identifies the data. Again, similarly, you can able to export the model and you can able to integrate into your project also. Okay. You can connect image processing connecting with this audio. I need to trigger it or something like that. You can able to do it. Okay, as you like. So you can able to integrate both the project on a single project. Okay. So it's up to you how you are going to integrate, how you are going to migrate, and how you are going to process. So these things are all individual. So I just shown the demo about what it is and how it is. Okay. Now I'll be explaining detail on what is deep learning. It is how the neural network works and what is the neural network structure is present. So I'll be connecting with that. Okay. Now, whenever I'm connecting, I'll be taking only the Intel based model. Okay, I'll be taking the presentation based on the Intel based one. So yeah, here also already the file is there. So before proceeding this, I'm just explaining this only one slide. If you are in the position to understand this slide, this is more than enough. Even if it is a supervised or unsupervised or whatever it may be, that doesn't matter. Okay. So this is the basic fundamentals of how these things are all getting connected. Okay. So we should have the mathematical capability. Okay. We should have the mathematical capability. We need to have the data with answer. I mean the trained data. Okay. So if you are having the trained data, okay, you are connecting to the mathematical model. Okay, the trained data connecting to the mathematical, you are trying to fit it. Okay, you are trying to fit it. Then after fit, you got a model. So this fit is nothing but what we did now, the training. Okay, so train the model. Okay, this is the training data set. Okay, so data with answers. So I shown the Azure board, I shown the MediaTek board. Okay, I took the pictures of the corresponding board. Okay, so the data with answers, I'm connecting to the model. Okay, so after fit, these both are clubbed together. Now I'm having a predefined model. In this model, I'm connecting with the test data. Okay, data without answers. So it will be predicting, okay, under which category is this? It will be predicting under which category is this based on the model that we trained. Okay, even in the speech also, even in the image also, I just shown you. Okay, so this is nothing but a fundamentals of ML. That's more than enough. I mean, I think already you knows about what is ML. So this is the basic fundamentals. The same methodology will be applying in a DL, in AI, and everything. Okay, so that's what I tried to show what it is. Okay, now I'll be explaining on neural networks. Okay, so if you are saying about the neural networks, okay, this is similar to what the human is having. Okay, this is similar to the human brain. Okay, how the neuron is connected. Okay, yeah, let's assume here multiple uh, uh, participants are there. So let's assume I am connecting to some person. I mean, let's assume I'm giving my hand to Dr. Arun. Okay, to Arun. Okay, so if someone is seeing, okay, whether I'm giving or not. Okay, so for them, so I'm just giving my hand to Arun. The next moment, the Arun is giving the hand to me. Okay, so in this, what happened means, okay, he is a machine. Okay, to him, okay, I'm connecting my hand. Okay, he receives the input via that camera. Camera means the eye, two eyes. Okay, so via the eye, he is receiving that image processing image that I'm giving hand to him. The next moment, okay, he is rotating his hand and he is giving his hand to me. Okay, so from others perspective, okay, he received the input is nothing but I'm giving hand to me. So that's nothing but an input layer. And he rotated his hand and he gave his hand to me. Okay, so that's nothing but output layer. Okay, this is input layer, this is output layer. In between what happened, that's nothing but a hidden layer. In between what happened, those things are all purely a hidden layer. Okay, so how these things works. Okay, so in this hidden layer, okay, there is a n number of neuron. Okay, based on this neuron, okay, so how these things are, 1 minute please. Sundar, kila Dhanamaka. So based on the neurons, okay, how these things are all connected together and how these things works. Okay, so that's a challenge. Okay, so how we are going to write the each and every neurons in a layer by layer fashion, such a way that it helps in the neural networks. Okay, so in general, okay, neural network is nothing but a series of algorithm that to recognize the underlying relationship in a set of data through process mimics by the human brain, how the human brain is operates. Okay, it can able to adapt based on the input. Okay, and again, I can able to explain in detail on neural networks and in detail. Okay, now I will be explaining about these layers. Okay, so this is a input layer. This is a input layer. This is output layer. The light blue is input layer, and dark blue is output layer. The orange color are all hidden layers. Okay, so each and everything is nothing but a neuron. Okay, okay, this is what the neural network structure will be. Okay, each and everything is considered to be neurons. Okay, so here for at this layer 2, this is layer 1, layer 2, layer 3, layer 4. 4 layers are there. At this layer 2, okay, so I'm connecting the data from all the data from layer 1. So this is fed to this is also fed to this is also fed to this. But what's the calculation that you are making? Okay, so for this neuron, okay, this gets the input from the previous layer. This gets the input 1, 2, 3, 4. All the 4 inputs from the previous layer, and it gives only one output, but this one output may be fed to the multiple neurons. One output may be fed to the multiple neurons. Okay, this is how the neural network structure works. This is how our brain also works. Okay, let's assume, I mean, just now I said an example. Okay, I'm giving a hand to Dr. Arun. Okay, I mean, if I'm giving the hand, let's assume he is closing his eye. He is not opening his eye. Practically, he won't give because he did not receive any input. Okay, now let's assume he is receiving the input. Okay, the next moment, what happens means, okay, once this is fed to his brain, okay, he cross verifies with the multiple condition statement that whether I look dirt or not. If I look dirt, he won't give the give his hand. Okay, so if instead of dirt, okay, if I'm looking in a different way means let's say I'm affected with the COVID, practically he won't come near to me. Okay, oh, 1 minute please. 1 minute please. Sundar, sorry. So practically he won't give his hand to me. So based on the multiple condition, how I'm dressing, how I looks, okay, he will be connecting with the multiple things. Then only he start giving his handshake to me. Then only he start giving his handshake to me. So this is nothing but a multiple layers. Okay, each and every conditional statement is nothing but a neurons. Okay, so they finally it fit to the output. So now I'm taking only one, instead of out of this entire neural network, I'm taking only one neuron sample. Okay, so this is the neuron sample. This is the input which we received from the previous layer. Okay, this is the function, activation function. This is the output. Okay, so the data from the previous layer, it's highlighted over here. Okay, now this is nothing but activation function. What are the transformation that occurs, we will be transforming those things. And this is the neuron output, that is fed as output, or that can be connected to the next layer. It depends. Okay, so here we are having a 3 different inputs. Okay, x1, x2, x3. Okay, even based on this x1, x2, x3, the weightages are different. Okay, so let's assume I'm giving my hand to Arun, and one more person also. Let's assume the person name is Sundar. He's also giving hand to Mr. Arun. Okay, so if Arun knows me well, okay, my weightage is different. If Arun don't know about me well, okay, that weightage is entirely different. Okay, so similarly, okay, if you are connecting the different input or different parameters, okay, each and every parameter is having that weightage is different. Okay, so that's what I mentioned. It's a W1. Okay, for the input x1, for input x2 it's a W2, for input x3 it's a W3. So here we'll be connecting with some error also. Okay, that's nothing but a bias. Yeah, here I shown. Okay, x1 W1, x2 W2, x3 W3 plus B. Okay, so the input fed to this activation function is x1 W1 plus x2 W2 plus x3 W3 plus B into 1. B into 1 is 1. Sorry, B. So that's what we fed to that input. Okay, so here that's what I am showing. So the total input, I'm naming it as a Z. Okay, Z equal to x1 W1, x2 W2 plus x3 W3 plus B. Okay, so if the input is given as Z, after the function, the output will be f of Z. Don't consider this is nothing but a Z transform. This is not at all a Z transform. So if I'm giving x as input, the output will be f of x. So like that, I'm giving the function as Z. I'm naming it as a Z. It's not a Z transform. So I'm getting output as f of Z for this particular only one neuron. So by mathematical way, we can represent like anything. Okay, like this. So this also I'm connecting with the neurons. So how you are going to connect entire thing as a neurons? So that's a challenge. Okay, so each and every neuron here I mentioned is x1 W1 plus x2 W2 plus x3 W3. So it's not a thing that always this should be like this. Okay, it can vary based on the data set, based on the input, based on the environment. N number of conditions are there. Okay, so it based on that. Okay, it varies. Okay, so in this I'm just showing in a generalized way. Okay, even I'll be showing with some coding example also how I'm connected. So those things are also you can able to see it. Even I'll be showcasing about the time series analysis also. Once you started to see those things, your understanding level is a bit different. So this what the each and every neuron is gets connected. Okay, so in this neuron, if I'm start saying about that algorithms, there is a number of algorithms like ANN. It's nothing but artificial neural network. This is under the vectorized way, and CNN is under a scalarized way, convolutional neural network, and RNN, recurrent neural network. So multiple algo is there. The thing is, whatever the algo, okay, those things are all predefined algo, the generalized algo that will be helpful for to do this process, but what's your mathematical calculation for your projects? That plays a big role. Okay, so using those algo, it's a different case. Whereas how we are designing the algo and how we are working with that algo. So there only we can able to see the challenges. Okay, so based on the challenges, how you can able to visualize it. Okay, so these things you need to consider it. Okay, if you are working with DL or something else. Okay, these things are all mandatory one. Okay, so now, okay, so this is a general mathematical calculation. So if I'm taking, I mean, I'll be explaining these things with the, I mean, the same methodologies with connecting with some numbers. Okay, so I'll be explaining these things with uh, demo. Demo means the programmable demo. Okay, even now itself I can show that, right? Yeah. So I'm connecting with the basic regression. So I'll be using a Google Colab. Google Colab is a cloud environment from the Google collaboratory. So where you can able to do the program for ML, DL, AI steps. You can able to get the results also. Yeah. So here I'm connecting with the necessary packages, NumPy, Pandas, Matplotlib, Stats Model, Seaborn, everything I'm connecting over here. Okay. Then I'll be connecting with the how to load the data. Okay, so even I can run it now also. That doesn't matter. So once it is connected, this is session based one. So it will be connecting, it will be allocating, and then only it will be the processing. Yeah, it's connected. slr.csv. So I connected those data set. Okay. So I connected. This also I connected. Here I added the NumPy. NumPy is a numerical package that most of you knows. Pandas. Okay. How to read the data. Okay. How different way you can able to read those data and do the manipulation. So for that you will be using a Pandas. Matplotlib is for data visualization. The stats model is nothing but stats model.api. This will be you are using for statistical analysis. And Seaborn, it's a top layer over the Matplotlib. Okay, so these are the packages that I'm using over here. Okay, so I'm connecting the dependent variable and independent variable. This is a formula for y equal to mx plus c. So I'm taking that data set. Okay, with the data set I'm just plotting using the scatter plot. Okay, now I will be using OLS, ordinary least square methodologies. OLS, ordinary least square methodologies. Okay, so I'll be cross verifying that result also. Okay, so once I identified y equal to mx plus c, so here already I defined what is dependent variable, what is independent variable. Okay, so in this x is independent variable and y is dependent variable, where y depends on x. Okay, so y equal to mx plus c. Okay, in this I'm connecting everything together. Here I'm getting the coefficient. Okay.
Sorry for the interruption, sir.
Yeah.
Sir, participants are asking to zoom the screen little bit so that it will be clear for them to view.
So, Is this fine?
Yes, it's fine, sir, now. Thank you,
Ah,
sir.
thank you, thank you, thank you. Hmm. Yeah, thank you. So I just take the session again. Okay, not in detail. So I'm connecting with the multiple packages. Okay, NumPy, Pandas. What are the packages that it is required? Even if you want to try, you can able to try also. Okay, even I can able to share now also. I'll share these details. So you can try in your PC also. Okay, so this is the program for how uploading the file. So I'm reading that particular file pd.read csv. Pd means pandas. Okay, so I'll be reading those data. So totally I'll be having 84 data. Okay, so data that describe means how the count, mean, standard deviation, minimum value, maximum value, these things you'll be knowing. Okay, so here I'm connecting the independent variable and dependent variable. Y equal to mx plus c means y is a dependent variable, x is a independent variable. X is not dependent on y, whereas y is dependent on x. So that's what y equal to mx plus c. So I'm connecting that y equal to mx plus c. Okay. So here I'm connecting with the scatter plot. Okay. I'm just visualizing the data. Okay. To I mean, this is for best fit line. I'm just connecting some the basic linear regression. Okay. So here I'm connecting with the ordinary least square methodologies. Okay, I'm connecting that result. Okay, if I'm connecting the summary of that particular result, here I will be connecting the coefficient and the exams like this. Okay, coefficients for constant and exam. Okay, y equal to mx plus c. I said right. This is nothing but m. This is nothing but c. Practically, for this data, what might be the best? We don't know, but we used it here. Okay, we identified the equation. Okay, now we are connecting with y hat equal to m x plus c. Okay, so I'll be plotting that particular y hat value also. So this is nothing but a best fit line. Okay, for this data set, so I'll be removing, I mean, here I'm connecting with the different test cases also. If I'm removing this will fall bit down. Yeah, yes, you can able to, I mean, you can able to see it. This will be fall bit down. Okay, so if I'm removing that m as a 0, okay, it will be like a straight line. Okay, it will be like straight line. So this is the best fit line for these data. So what might be the next result? So it will be predicting based on this. So that's what that ordinary least square methodology works. Even I'll be explaining you with some more derivation also. I mean the mathematical way also. Uh, so whenever I'm connecting with y equal to mx plus c, okay. So by basic, this regression is having the data set of this is the exam, this is the GPA. Okay, so this is x and this is y. Okay, already we got the solution, but we are identifying the best fit line for next level of prediction. Okay, so for those cases, that predicted value is nothing but a y hat. Okay, the normal thing is nothing but a y. The normal thing is nothing but a y. So that's what I'm showing here. So I think this graph will be visible to everyone. So this is x and this is y. Okay, so we are having a y. Okay, in a different way. So I'm connecting the mean value of y, the general y. So this is nothing but a mean value of y. Okay, so but I'm taking a sample at ith value. Okay, it can be any value. So I'm taking a sample. Okay, so let it be yi. Okay, for that yi, okay, the actual value will be here. but as per the predictive things, this is the line that it falls. Okay, but at this x value, okay, this is false. So here I'm identifying this is the predicted value, this is the actual value, this is the predicted value, and this is the actual value. Okay, so that's what I'll be connecting with the mathematical expression that SST equal to SSR plus SSE. So SST is nothing but measures the total variability of data sets. I mean, it's a difference between the actual value with the mean. It's a difference between actual value with the mean. Okay, so, this is connecting with the mean square. Okay, so for I equal to 1 to n, I mean, if I'm connecting only one, so this is nothing but yi minus y bar the whole square. If I'm connecting for all the I value, so this is nothing but summation I equal to 1 to n yi minus y bar the whole square. Okay, this is nothing but a SST. Okay, sum of squares of total. We'll be saying it as sum of squares of total. Okay, and then SSR nothing but a y hat minus y bar, y hat minus y bar. Okay, I mean yeah, y hat, this is minus y bar the whole square. Okay, so for one value it is y hat minus y bar the whole square. For n number of values, so I equal to 1 to n y hat minus y bar the whole square. Okay, this is sum of squares of regression. Okay, so the another name is explained sum of square. Okay, and the finally SSE, this is nothing but a sum of squares of error. This is nothing but a y hat minus yi the whole bar. I mean yi the whole square. So this is the difference. So this is the actual value, this is the predicted value. So if we are having a difference, that's nothing but a error. If both are same, we are not having the error. Okay, so it calculates for the entire thing and then only it gives the result. So that's what I'm explaining in a mathematical way, how this algorithm works in the background. Okay, so y hat minus y hat of I minus yi the whole square. Okay, this is the error. Okay, if both are predicted, then the error is nil. Okay. So this is nothing but the total variability is nothing but explained variability and unexplained variability. So here we are connecting with different. There will be n number of methodologies. Here I'm just showing with ordinary least square methodologies. So that's what I written here. Okay, this is to minimize the SSE. Okay, again, whether always the OLS is best, it's not like that. Okay, for this data set, OL is best. Okay, even I'll be showing with stats model web also. Okay, how these things are there. There you can able to identify n number of methodologies. Okay, so here this is the diagram that I'm showing to you. So n number of lines, regression line we can have, but it will be identifying the best fit line. Okay, based on the least error. Okay, so OLS methodology, ordinary least square. Okay, so it identifies the least error. Okay, so this is the same thing. So in this ordinary least square, I'll be connecting with R square. Whereas while you are seeing, not this one. Here R square value. You might have seen the R square value, right? So we are having n number of parameter. Okay, if the R square value is less, our model is best fit model. So that's what I'm explaining. Okay, R square is nothing but a ratio between SSR to SST. Okay. This will range from 0 to 1. If both are same almost, if the R square value is very low, that means it's a best fit. The we can't say if it is less, it's a best fit line. So for some other project, if it is varies, that might be the best project. Again, it's based on the data set. Okay, data set, how we are connecting. Okay, so, don't for this, if R value is lesser, for this data set R value is lesser, then it's a best fit. Okay, so again, it based on the projects. Okay, how we are connecting. Okay. Okay, so this what okay, that's it. I think we got about what is the mathematical background happened in OLS methodology. Now I'll be showing with okay. So this is the stats model packages. So I'm just connecting that stats model package. I'm connecting the API references. So if I'm connecting the API references, so here for regression, here you are seeing ordinary least square, the generalized least square, n number of methodologies there. In these packages, what are the methodology you feel comfortable, you can use those methodologies. Okay. Again, based on the data set only, you can able to define it. If you are asking for this data set, whether this will be applicable, yeah. Again, it's based on the experience only, you can able to identify for which data set, which model will be applicable. Okay. So for imputation, what are all the model is available. Okay. So here for linear model, discrete counts. Okay. So everywhere, what are the model is available, you can use those model such a way that you can get those details. Even in ARIMA, the time series analysis, I'll be showing those demo also. Okay. So these are all the different packages which is available. Okay. You can utilize those things and such a way that you can connect to your data set and you can see the result. Okay. So this what you can able to do it. Okay. So even I can give some examples about some other project also. Okay. So this is a simple regression. Instead of connecting with the simple regression, I can able to connect with let's assume the logistics. Okay. The same data sets connecting with sorry. Okay. So here I'm having the mark. Okay. If I'm getting the mark, whether I'm admitted to the college or not. Okay. What's the gender of those people? So I'm having around 168 students data. Okay. But with that 168 students data, how we can able to calculate it? Okay. So I just explain this and I'll be explaining the mathematical way for that also. Then I'll be taking about the CNN and time series analysis. Okay. So now I'm just, so here I'm using the Skype also. So I'm connecting that corresponding data set. So this is already I run, so that's what it shows the result. Okay. So I'm mapping the people who are all admitted as a 1 and who are all not admitted as a 0. And in gender category, in admitted, I can't do the program with yes, no. I can do the program with 1 or 0 and it should have some flags. So I'm just connecting with 1 and 0. Okay. So, yeah, here it's changed. Admitted as 0 and 1 and gender as 0 and 1 if we are having 3 different cases, so 0, 1, 2, you can use. It's up to you to use. So here I'm declaring the independent variable and dependent variable, whereas admitted will be the dependent variable. The marks and gender is independent variable. The marks are all not at all related to admitted. Okay, but admitted is related to marks, and gender is also not related to admitted, but admitted related to gender also. So that's what I'm connecting. So these two are all independent variables. This is nothing but a dependent variable. Okay. Then I'm connecting with a logit function. Okay. So here I'm connecting with the logit function. So once you started to see y equal to, previously I said, right, y equal to mx plus c. Now the equation bit changes. Okay, y equal to m1 x1 plus m2 x2 plus c. Okay, so here the c is this one. Okay, m1 m2 and x1 is a different and x2 is different. So I'm just connected to that. Okay, so how many observations made? Okay, so all these things we identified it. Okay, here log Likud function, I mean pseudo R squared also is there.
Sorry for the interruption again, sir.
Yeah.
So if you could please zoom in. Yes, sir. It will be better for the participants to view, sir.
Oh, okay, okay, sure.
Thank you, sir.
Thank you, thank you. Okay, so I'll be using the logit function. Even this logit function, I can able to connect in this control F. UGIT. Yeah. Here also the discrete count model. I can utilize this logit function also. Okay. So the same logit function I'm using here. Okay. I'll be calculating these things. Okay. So here what I'm trying to do, it means okay, I'll be calculating the accuracy. Okay, how these things can be predicted. Okay, so based on this calculation. Okay, so here in this log table, okay, I'll be connecting with the confusion matrix. This is nothing but a confusion matrix. The CM is nothing but a confusion matrix. With this confusion matrix, I'll be calculating the predictor as 0 and the predicted, I mean, actually 0, the predicted is 0, actually is 1, the predicted is 1. So practically we can able to identify out of these values the accuracy for this data set with the logit function will be 94.64%. Okay, even I'll be connecting with one more program, the same program in a different way. So I think you can visualize it. Okay, so here in this also you can able to connect with the logit function. Okay, with this logit function, okay, not in this, the previous program. In this logit function, we can able to visualize that the people who are all admitted, I mean, with this I can plot a graph. Okay, so this is what I try to do. Okay, the thing is this probability regression which helps you to identify, okay, if it is admitted, okay, how many genders are all admitted together. Okay, in this admitted case, practically you can able to visualize that out of 8 out of the entire structure, the people who are all got admitted, okay, the girls are all got admitted to this college. So these things can be visualized in these cases. So these regressions or these probability regression, these things are all helpful for if you are connecting the more data set, okay, where if you are getting, if I'm taking a particular mark and connecting to the unhonesty, if you are seeing that mark, the practically you will be saying, yeah, if you are getting this mark, you may get admitted, you may not be admitted. If you are getting admitted in unhonesty, under which course you can able to get it, these courses are, or you won't get it. So these things you can able to say just like that. Whereas if it is around 1 lakh of data, how will you do? So practically that's a challenge. So for those cases, these binary predictions will be helpful. For those cases, these binary prediction can be helpful. Even I can show the mathematical way also. So this is a logistic regression. By using the linear regression formula, y equal to mx, that's what I said. Okay, y equal to beta naught plus beta 1 x1 up to beta k xk, and this is here. Okay, this is for linear regression. Okay, for logistic regression, p of x equal to e power of beta naught plus beta 1 x1 up to beta k xk divided by 1 plus e power of beta naught plus beta 1 x1 up to beta k xk. This is the logistic regression formula, but we are using logic formula. We are not using logistic regression formula. Okay, so for that case, okay, I'll be how we are changing the formula. So I'm just in the right side. Okay, I'm taking the denominator to the left side. So p of x into 1 plus e power of beta naught plus beta 1 x1 up to beta k xk equal to e power of beta naught. Okay, I'm taking those things. So now I'm multiplying it. P of x is nothing but p of x into p of x, sorry, p of x plus p of x into e power of beta naught plus beta 1 xk up to beta k xk equal to e power of this one. Okay, so p of x equal to this one I just did. Now it's nothing but a 1 minus p of x into e power of this one. Okay, so now p of x equal to p of x by 1 minus p of x equal to e power of beta naught plus beta 1 xk plus up to beta k xk. So this is the odds ratio. This is nothing but a odds ratio. Now if I'm taking logarithmic on both the side, okay, if I'm taking log on both the side, okay, log of p of x by 1 minus p of x equal to log of this one. So this is nothing but this one. So this is nothing but a general model. Okay, now this is nothing but a log of odds ratio. Log of odds ratio. Okay, odds of getting 6. Okay, probability of getting, probability of not getting. Okay, so p of x is nothing but a probability of success. Q of x is nothing but a 1 minus p of x. That's nothing but a, here it's not getting. So this how you will be getting the odds ratio. Okay. So log of odds ratio is nothing but a linear model. Okay. So for the model which I'm connected, okay. So if I'm considering 2 log function, the odds 2 will be odds 1. Okay. So for different samples, consecutive samples, the two different consecutive samples. Okay. This is, let's assume this is the equation for the sample M1 and sample M2. So I'm just subtracting both the thing. Okay, log of odds 2 minus log of odds 1 divided, equal to this one. So practically what I'm getting means, okay, log of odds 2 divided by odds 1 equal to 0.042 into M2 minus 1 M1. Let's just say if M2 minus M1 is 1, okay, log of odds 2 by odds 1 equal to 0.042. So taking the E exponential, then odds 2 by odds 1, this is nothing but this. So if we are taking 2 different samples, I can be able to visualize how much the data rate or how much the next value it gets changed. So these things I can able to visualize easily. These things I can able to visualize easily. So that's what here I'm connecting with instead of M1 and M2, I'm connecting with the 2 different genders. Okay, male and female. The same equation, okay, what we got, Okay, I'm connected with that. Okay, so gender 2 is 1, gender 1 is 0. Let's gender 2 is female, it's male. Okay, 1 minus 0 is 1. Okay, so practically odds of female divided by male equal to e power of this one. So odds of female equal to this one. So each and every 8 females we can able to visualize 1 male. So here we can able to visualize the probability of that particular college. I mean to get the seat, the female students is high compared to the male students. Okay, this what we'll be calculating. Okay, how these things, these statisticals can be analyzed. And again, this is a single neuron. Okay, so by connecting this multiple neuron, you can able to visualize how these things can be done, how the manipulations can be done. So everything you can able to reprocess it again. Okay, you can again, it's based on the developer. Okay, so this how the odds to do the odds. This is nothing but the logic function. Okay, so based on this only, this logic function will work. Okay, so this is simple one. I mean, if I'm connecting for 1 or 2 hours, so I can able to show the examples which is easier. Okay, that's what I'm trying to show you. Even I'll be showing with one more example. Then I'll be connecting with the time series analysis and CNN. This not this. Even I can while I'm connecting the time series analysis, I can show the AI also. Okay. Now I'll be connecting with clustering. Not this one. Yeah. So in this clustering, okay. So I'm not going to add the data and I'm not going to run. Okay. So I just show you how this gets processed. Okay. Even if I'm saying about the clustering, I'll be taking with the k-means clustering. Okay. So if I'm connecting with the clustering, this is how you are going to group the data together such that you can able to visualize it. But practically before clustering, everything will work. Okay. Without doing the clustering also, everything will work. But if you are grouping, how you can able to analyze or visualize the entire structure. So for that only, I'm just saying about the clustering. Okay. So here I'm taking an example of these countries: Canada, Australia, USA, UK, France, and Germany. If I ask you to, can you able to cluster? Yeah, you can able to say that Canada and USA together, Australia is another way, and UK and UK, Germany, France in European countries. Okay, so we can able to cluster in 3 different ways, or we can able to cluster like Canada, USA, Australia, UK are speaking English. France is another cluster. German is in a third cluster. Okay, you can able to use, but I'll be explaining you about the mathematical way how these clusters are working. Okay, so just now I said, right, I can able to cluster it like this. I can able to cluster like this also. Even, yeah. Okay, let's assume we are having data. Okay, so for x-axis, y-axis, we are having some data. Okay, here this is another data and this is another data. Okay, here we need to identify the Euclidean distance between these 2 points, this point and this point. According to Pythagoras theorem, we can able to connect like, okay, this distance is nothing but, okay, squares of the diagonal is nothing but this and this. So you can able to calculate like that also. Okay, so that's what I'm processing. This is nothing but 7, this is 2. So I'll be using the Pythagoras theorem. So I'm calculating the Euclidean distance. Okay, based on this Euclidean distance, how these clustering is works. Okay, so if it is a 2 data, so I can able to say x2 minus x1 the whole square and y2 minus y the whole square. If it is a 3-dimensional space, okay, x2 minus x1, y2 minus y1 and z2 minus z1. If it is a n-dimensional, okay, it's a1 b1 a2 b2 up to a and bn. Okay, so this is the formula for how to calculate the Euclidean distance. Okay, so we'll be having 2 different points. Okay, again, in a data set, if you are having 1000 different points, for each and every point we'll be calculating Euclidean distance between other 999 points. Okay, so almost this is a big space. Okay, all the calculation can be done, but we are taking a sample and we'll be identifying how the mathematical background for that particular thing. So that's what I'm explaining to you. Okay, let's assume, okay, we are having how we are grouping. So that's what I'm trying to explain. Okay, let's assume we are having 2 different points. This is the point 1 and this is the point 2. Okay, so midpoint between these 2 points is nothing but a centroid. Midpoint between these 2 points is nothing but a centroid. Okay, we can able to place the centroid at anywhere. Okay, by calculating the Euclidean distance, let's assume if I'm placing the point over here, okay, the centroid point over here, somewhere, draw like this. Centroid point over here, it will be calculating the distance and it will be calculating this distance also. Okay, so and also it will be calculating this distance also. Okay, it identifies this is the midpoint. No, again the transformation is done again and again such a way that this point will reach this place. Okay, so this is the repetitive process. Okay, for how to connect with the centroid. Okay, now if it is a 3 different point, the centroid might be like this. If it is a multiple different point, the centroid is different. Okay, based on the centroid, the points are grouped together. Okay, if I'm having only one centroid, it will be like this. If I'm having 2 centroid, the case is different. So that's what. Okay, so if for these 3 points, this is the centroid. For 1000 points, this is the centroid. Okay, so here I'm having some data. Here also I'm having some data. Okay, if I'm connecting a centroid, one centroid point will be somewhere here and another centroid point will be somewhere here. If I'm having only one centroid point, I'll be changing the color. If I'm having only one centroid point, this is somewhere like this. Here I connected two centroid point. For this centroid point, this is calculated. For this centroid point, this is calculated. So for this centroid point, I'm calculating the Euclidean distance such a way that everything falls under this centroid point. So now this is considered to be a one cluster and this is considered to be another cluster. Okay. So that's what I'm showing here. This is the centroid for this cluster. Okay. Here, if I'm connecting one more centroid point like this, okay. Now the new centroid point will be like this. This will be comes here and this will be comes here. So the groupism can be done somehow like this. The clusters. Okay, that's what I try to show you. Okay, so each and every centroid, how many centroids you are choosing? Okay, so that much of clusters will be having. Okay, by basic, it identifies the distance and it connects to the centroid and it calculates with that centroid. Okay, so In this k-means clustering, we'll be having 4 different ways. One is choose the number of cluster. Practically, if you are asking for 100 points or 1000 points, can you able to see how much clusters can we have? Practically, it's impossible to say the answer. Okay. So for this, we will be having some methodology like heat map and elbow method. I'll be explaining those heat map and elbow methods also. Okay. So the first step is choose the number of clusters. Randomly, you just choose number of cluster. Then we can able to connect with the elbow method. Okay, and specify the number of seeds. Okay, so we need to specify somewhere. Okay, like here or here. I mean here or here. Randomly you can specify it, but you can choose bit closer to what you are going to choose. Okay, so assign each point to a centroid. Okay, now then you'll be assigning each point to the centroid, and you'll be adjusting the centroids such a way that you can able to do the process. Again, for this centroid, you need to repeat the steps again and again such a way that until you get the best success, you have to repeat the step. Then you will be getting the best success. Okay. Now I'm considering this sample. Okay. So these are the data. So now I'm going to choose 2 clusters. Okay. So I'm choose 2 clusters. I'm placing those cluster seeds also. So practically, this will be having distance. This point is also having almost same distance to orange and green. Okay. Now practically this centroid will move somewhere like here, and this green will move somewhere like here. Okay. Okay. Before initiating it, the shortest distance. This is the shortest distance. So now this falls under green, and this also falls under orange. So like this it can happen. Then these 2 points are somewhat closer to this cluster. Okay, this is the procedure we did. Okay, so after this process is done, now this green point is somewhat closer to this while compared to the orange point. Orange is in right. So now practically what happens, this will migrate to this place, and this will slightly shift to this place, and these 2 color will change into the green. Okay, this is the process that we are repeating. The step 2 and step 3 we are repeating. Okay, so these 2 are same. We need to redesign again. So now this is moved somewhere. This is also moved. Now we are having the exact clusters. So 2 clusters. If I'm choosing 2 clusters, if I'm choosing 3 different clusters, okay, randomly this orange will move somewhere here, but whereas the red will move somewhere here, and these points will, I'll be showing these points will fall under the green also. These 2 points will fall under the green also. Okay, by repeating the steps again, the red will move somewhat here, and the green will move somewhat here. Yeah. Okay, so the same data set, if I'm considering 2 different clusters, what happened? 3 different clusters, what happened? Everything is processed via the Euclidean distance. Okay, I just explained it. Okay, how to calculate the Euclidean distance, not only between the 2 points, and also connecting to the center. So each and every point has to be calculated. Okay, so I'll be explaining this method while after I'm giving the demo. Okay, after I given the demo, I will explain this method. So now I will be opening this. cluster analysis, I'll be using the scikit-learn. I'll be importing the k-means algorithm. Okay, so I'll be adding those data. So I'm using the country, corresponding latitude, corresponding longitude, and corresponding language. Okay, so I'm considering French as a 1, German as 2, and English as 0. I'm mapping it. Okay, so again, if I chosen 3 different clusters. Okay, if I'm using 3 different clusters, the point is moved to that. Here, there won't be any Euclidean distance. Okay, and the point itself is a clusters. Practically, if you are using cluster, it won't show the centroid point. It will show the clusters with the different colors. That's it. It won't show the centroid points. It won't show the centroid points. Okay. So, so in this, okay, how many clusters we identified? Okay. So if you are considering the language, how it will be 0, 1, 2. Even if I'm connecting the language as other than English is 1 means it's 0, 1. The cluster will be entirely in a different case. Okay, it processes and it identifies the clusters. And here there is a concept called WCSS, within cluster sum of squares. Okay, so if you are having 3 different clusters, okay, we identified some. We identified some values. So the maximum cluster for this will be a 6, and minimum cluster for this will be 0. Okay, we'll be calculating for all the value what might be the WCSS within cluster sum of squares. Okay, we'll be calculating those points. Okay, sorry, I forgot to zoom. So we are connecting with the inertia method. In this, I'm just plotting all the WCSS value. So if it is a 1 cluster, okay, what might be the value? This is around 42,605. Now 13,000, 290, 113, 39, and 0. If it is a maximum cluster, WCSS is practically 0. Okay. So this will be here. We can able to see a bend over here, and also we can see a bend over here also. Okay, 2 bends we can able to see it. Okay, so we need to identify the bend which is happened at the lowest value of WCSS. Yeah, here it happened. Okay, at 3 clusters it happened. So for this data set, 3 clusters are all advisable. For this data set, we can see 3 clusters are all advisable. Okay, so that's what. Okay, here also one bend, here also another bend. Here only I am identifying it. Okay, so practically we can have 3 clusters. Okay, so we are calculating which will be the best one means these 3 clusters. So this is nothing but this is something like a elbow bend. This is something like a elbow bend. That's what it's named it as elbow bend. So now I'll be connecting to the elbow method. Okay, here minimizing. Okay. So here the maximum, if the maximum cluster and maximum observation are same, the WCS is 0. Okay. If it is if the cluster is 1, WCSS is maximum. Okay. So this sort of the WCSS we can able to visualize. So the thing is, for n observation, the cluster should have less. Okay. So where the WCSS is low, okay, we can able to see the bend visualization. So this is what I just explained, right? So I took the same screenshot and I just shown you. Okay, this is how this works. Okay, there you can able to visualize the elbow method. Okay, so this is what we can able to identify how many clusters for this data set. So at the initial stage, practically it's hard to identify. Okay, by doing this method, we can able to define how many uh, clusters we can able to choose. I mean the groups, okay, or the centroid, whatever it can be. Okay, so if I'm connecting with the clustering of clustering, there is a homoclustering, heterogeneous clustering also is there. Okay, and two different way, augmentative and divisive. Okay, one is a bottom-up approach, another is a top-down approach. Whatever it may be, these things can be viewed with the heat map methodology also. Okay, so yeah, in augmentative, okay. So if I'm saying animal, it's a terrestrial, aquatic. In aquatic, there is a n number of groupism we can able to connect. Even if you are connecting the students, okay, most of you are all faculty. The students who are all got more than 8 CGPA, less than 8 CGPA, whereas it's greater than 6 CGPA. These persons can do this. So lots of clustering you are doing, but you can able to do this clustering by doing this mapping. If it is a 60 students, these things are all, it's not a big task. If you are having around 2 lakhs or 3 lakhs of data, then only the clustering plays a vital role. Okay. Okay. So in this dendrogram, I'll be connecting with the heat map. So this is nothing but a heat map. So I'll be showing that heat map also in a demo. Even if you need, I can share this program to you guys. Heat maps. Yeah. So the same latitude longitude I just took. Okay. So in this latitude longitude, if I'm connecting that heat map, this is the generalized data. Okay. So here these things are all connected. The Canada, USA are connected together. German, France are connected together. And UK also connected together. For everything, the Australia is a different case. So this is happened based on the latitude longitude position. Based on the latitude longitude position. By seeing this, okay, if you are slicing over here, you can calculate how many clusters it can be. If you are slicing over here, how many cluster it can be. If you are slicing over here, how many. So these things you can able to visualize it. Again, it's based on the individual. Practically, no algorithm will give the defined result. Okay, it's based on the developer, how they are working. Okay, how they are thinking. They are only this clustering or this groups and these things will work. Okay, so it's purely based on that particular individual developer. Okay, so suddenly in a retail market, sale is happening, but we don't know in what product we need to categorize it. So how many age group people are visiting to particular shop again and again. Okay, so we need to calculate those age group people. Okay, so under which age group are the coming again and again the repeating customer. Okay, so again in this repeating customer, what are the products that they are buying. So by analyzing these things, we can able to add the volume of that particular product such a way that we can have the profitable way of business. Again, I'll be showing with some other time series analysis demo also how we are connecting to the supply chain management also. Okay, so everything is based on the individual person. Okay, even if you are working, you are getting some result. I am working, I'm getting some result. Both are different, and we both are using the same methodology. But whereas how we are calculating, if you are connecting the generalized algo, we will be getting the same result as a generalized, but we need to modify the algo such that we can able to get the proper result. So this how these algorithms ideas are all. Okay, so now I'll be giving the break from 11 to 11:30. Okay.
Yes, sir. We can have a break for half an hour. Then we can continue the session, sir.
Yeah, sure.
Thank you, sir. Thank you. Mitresh, you can stop the recording now, and by 11:30 you can restart it, and sir will continue by 11:30. I request all the participants to have a break for another 30 minutes, and sir will be continuing the session from 11:30 to 1. Thank you all for